This video is about the trig function called tangent. Previously, we used the coordinates of a point on the unit circle determined by an angle theta to define our sine and cosine functions. The x-coordinate of the point on our unit circle determined by theta is cosine of theta, and the y-coordinate of the point determined by the angle theta on our unit circle is sine of theta. Similarly, we're going to define our tangent function in terms of x and y. In fact, tangent theta equals y over x. Now, since tangent of theta equals y over x, and y equals sine theta, and x equals cosine theta, we can write tangent in terms of sine and cosine. Furthermore, sine of theta equals the side opposite of theta over the hypotenuse, and cosine theta is equal to the adjacent side over the hypotenuse. We can simplify this, and we get that tangent of theta is equal to opposite over adjacent. So coming back to our unit circle, for our angle theta here, tangent is equal to our opposite side, which is y, over our adjacent side, which is x. Now let's go back to the point P on our unit circle and consider its slope. This point also goes through the origin, so the slope of our point, or of our line that goes through P in the origin, is y minus 0 over x minus 0, and that simplifies to y over x, which happens to be tangent of theta, for whatever theta might happen to be. So we can always think of our tangent function as being the slope of this line here. So the terminal side of our angle theta. So intuitively, the slope of the line when theta is 0 is going to be 0. So the tangent of the angle 0 is 0. Now, as our angle theta gets closer and closer and closer to 90 degrees, our line gets steeper and steeper and steeper. So that means that our slope is getting bigger and bigger and bigger until eventually it becomes undefined. So that means as theta approaches 90 degrees, our tangent gets bigger and bigger and bigger and bigger and bigger, so it approaches infinity. So then when it gets to be perfectly vertical, it's undefined, because you can't actually have a slope of infinity. Now I'm going to plot the graph of theta versus tangent theta. So like I just mentioned, at 0, our tangent is going to be 0. That's a point right here. If we go back to our graph, we can see that for 180 degrees, we're also going to get a horizontal line, so that's going to be a slope of 0. The same goes for negative 180, positive 360, and negative 360. Since for the angles positive and negative 90, or you could also think of them as positive or negative 270 degrees, both of those angles will give you terminal sides that are vertical, so they have undefined slope. So at 90 and negative 90, or negative 270 and 270, we're going to have asymptotes on our graph of tangent. And then one last look at our graph. Let's see, as our angle goes from 0 to positive 90, our slope increases. And then as our angle goes from 0 to negative 90, our slope decreases, because down here we'll have a negative slope, and up here we'll have a positive slope. So that'll be reflected in our graph, just like this. So this is our graph of tangent. From the graph of our tangent function, if we start right here at the origin, we can determine the period of our function to be 180 degrees. So notice this is different from the period of sine and cosine, which were 360 degrees. Alright, and then just a general summary of some information about our cosine, sine, and tangent functions. The period of sine and cosine are 360 degrees. The period of our tangent function is 180 degrees. The domain of our sine and cosine functions are all real numbers, so negative infinity to positive infinity, and then both of those functions also have the same range of negative 1 to 1, with the square brackets to indicate that those endpoints are included in the interval. And then the domain of our tangent function is everything except for theta when theta is a multiple of 90 degrees. So theta can't be any multiple of 90 degrees because those are the asymptotes on our graphs. So this is 90 degrees, or odd multiples, sorry, of 90 degrees. So this is 90 degrees, 3 times 90 degrees, negative 1 times 90 degrees, negative 3 times 90 degrees. So once again, the domain of our tangent function is every theta except for odd multiples of 90 degrees, and then the range of our tangent function is all reals, so from negative infinity to positive infinity.